All right. Got it at full screen. Page 206. Exercises 4.3. Other number bases. Okay, the one you work in is the decimal system, the base 10. All of you know about that, don't you? Let me back up here a little bit and put something up here. So your base 10 is 10 to the 0, and then 10 to the 1, and then 10 squared, and then 10 to the third. And this is the ones place. This is the tens place. And of course, what's 10 to the second? This is the hundreds place. It might be a while. Probably you saw this somewhere in grade school. This is the thousands place. So, 2,463, that's the way we read it, but that's 3 ones, 3 times 1, 6 times 10, 4 times 100, and 2 times 1,000. If you were doing it in expanded notation, like we did on Wednesday, you follow that? Have all of you seen this somewhere before in your life? If you don't remember it, you probably saw it in grade school. But the reason I'm putting it up here is now we're going to take this same system and say, guess what? Instead of base 10, we're going to use, for problem 2 on page 206, we're going to use base 5. And how do I know it's base 5? See that little red circles? How many little asterisks in each circle?
5.
5 of them. So since there's 5 of them, I know it's base 5. And how many groups of 5 do I have there? How many little? Problem 2 on page 206. 3. So that's where this 3 comes from. Whoops, that's supposed to be red. That's where this 3 comes from. I have 3 5s, because see, base 5 would be 5 to the 0, which is ones, 5 to the first, and then 5 to the second. Now this is where it gets tricky, because this is ones. Okay, that's just like in our system. But see, then this is 5s. And then what's 5 squared? You're not going to tell me. 25. So what I have here is 3 5s and 3 1s. You follow that? In the base 5. 3 5 and 3 1s in the base 5. So when they tell you a different base, really, whatever, just like in our base 10, you've got your place values here. Anytime it mentions another base, you just simply put the base up there and have it to the 0 power, to the first power, to the second power, to the third power, and just go as many places as you need to do the math. Okay, problem 4, red circles. How many asterisks in each circle? That's base 10. And then how many circles are there? Red circles, 3. So I put down a 3 in the tens place. And how many individual units? 1, 2, 3, 4, 5, 6. So I put a 6 down. You follow what's going on? So problem 6. Draw a picture, draw a diagram is what it said to do, like problems 1 through 4. So draw a diagram for 15 in base 5. So if it's base 5, that means I'm going to have circles of 5. So what I really do is I can make X's easier than I can make asterisks. So I just made 15 x's and then circled them, put them in groups of 5 because the base is 5. So there's my 15. So what's this numeral? 3 0 in the base 5. 3 5s and no 1s. You follow what I did? Let's do 15 in the base 12. So now I put 15 x's up here, but I put a group of 12 together because that's the base we're working with. And then if that's 12, then I have 1, 2, 3 to make a total of 15. You follow me? I have 15 x's. I could have put the other 3 x's out here and then just circled. Could have just stuck 15 x's in a line and then circled 12 of them and then see what's left. But when I get through, what do I have for an answer? Is that beautiful? I mean, do you get a little rush of adrenaline when you go 1, 3? It's not 13. 13 is what we do in decimal. When you go 1, 3 in the base 12 is equivalent to 15 in the base 10. You follow that? That just looks pretty to me. I mean, that 1, 3 in the base 12, I just think that is so cute. Well, okay, let's do number 10. In problems 9 through 16, write each number in decimal notation. So what that means is I have to look at this number here and say, what is this saying? Now, can anyone read this number based on what we've been doing so far? How would you read this? You don't say 31. That's decimal. That's decimal talk. This is 3 1 in the base 5. And if it's base 5, then I put my little place value system up here, and I have 3 what? 3 5s. What's 3 5s? 15. And 1 1. So I add 15 and 1 together, and there it is, 16. So what's 3 1 in the base 5? It's 16 in the decimal system. Are we having fun yet? You must have been up awful late last night because you don't look like you're having as much fun as I thought you would today with this. This stuff is just so cool. It's so mind expanding. Number 12. 5 6 3 in the base 8. Do you see how to read that? And there's the base. Base 8. So I go 8 to the 0, 8 to the 1, 8 to the 2. And since I'm having fun with it, I just go 8 to the 3 just to put an extra one up there. You could just keep going as far as you want. And what's 8 to the 0? That's 1. What's 8 to the 1? That's 2. What's 8 to the second power? Everyone see where I get 64? It's 8 times 8. It's not 8 times 2. It's 8 times 8 is 64. And does everyone see how I get 512 for the fourth place? What's 8 times 8 times 8? We maybe better get our calculator out here if we just don't feel like doing mental math today, or it's not that little tired. Turn this thing on and go 8 times 8 times 8 equals 570. 512. Do that again. 8 times 8 times 8 equals, there it is. I punched a button. Have you ever made that mistake working in math? Punched the wrong button on the calculator? We think calculators solve all our problems. No, they don't. They don't tell us when we punch the wrong button. So I'll check it again. Since I 8 times 8 times 8 equals 512. So 8 to the third is the 512. Now, so what do I have here? I have 5, 8 to the seconds, 6, 8 to the first, and 3 in the ones place. So what's 5 times 64? 64 times 5, 320. Because I'm changing from base 8 over to decimal. And what's 6 times 8? Oh, I don't have to do that. That's 48. And what's 3 ones? 3. So I add 320 plus 48 plus 3 equals 371 in the decimal system. You see what's going on? So now you know basically the strategy for thinking and or for doing math in a base other than base 10, other than the one you've learned. I mean, it's almost like we just sat here today and learned. It'd be like being in English class where we just took a little time to learn a little bit of French, a little bit of Russian, a little bit of German. You understand? We're learning how to speak different mathematical languages. That still doesn't get you excited, does it? I'm just not gonna get your adrenaline going. I can tell by the looks on your faces. Number 14. All right, you're gonna like this one. I know you're gonna like this one. Number 14 says 101001 in the base 2. Now, base 2 is really cool. If you don't know that yet, you will when we're finished. But since it's base 2, I have 2 to the 0, 2 to the 1, 2 squared, 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th. And I'm just putting an extra one up there just because it's fun to do it. Just so I have all my places. So now, what do I have? 101001. It maybe doesn't hurt to start over here. 100101. So now I have 1 in, what's 2 to the 5th? 2 times 2 is what? We can do this mentally. 4 times 2 is 8, times 2 is 16, times 2, 5 times is 32. So that's the 32 place. So I have 132, so I write that down. I have no 16s, 0. This is what's cool about binary. You either have one or you don't. So it's either 1 or 0. You only have 2 digits, 0 and 1 with binary. So it's really cool that you don't have to do a whole lot of mental math with binary stuff. So we have no 16s, we have 1, 8, we have no 4s, we have no 2s, we have 1, 1. So what's 32 plus 8 plus 1? 41. So watch this. 101001 in binary, which is base 2, equals 41 in the decimal system. Questions? Okay, let's move on. But do you see how I'm making these place value charts? It probably wouldn't hurt for you to have a page of place value charts so you don't have to keep. See, I like making them, but if you don't, then just make one chart and then say this is the place value chart for base 5, this is the one for base 12, this is the one for base 8, and just make a chart, and then you can always look at it whenever you're working a different kind of problem. And that'll really expedite things for you when it comes time to take the test. All right, here's one that I don't think anybody likes, but it's still kind of cool. It's just from binary to base 16. This is problem number 16. Isn't that cool? That problem number 16 is base 16. But see, now think of the problem. If we have 16 places, we only have what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So guess what? For 10, they use the letter A. For 11, they use the letter B. It's on page 203, and you probably ought to put this in your notes because you're going to need it for the test at the end of this chapter. For 12, they use the letter C. For 13, D. For 14, E. And for 15, F. So now you know what A stands for. Oh, first we better make our chart, shouldn't we? So we have 16 to the 0, 16 to the 1st, 16 to the 2nd. I put 16 to the 3rd up here, but I didn't do it because we only need 3 places. So what's 16 to the first, or to the 0? That's 1. What's 16 to the first? That's 16. What's 16 to the second? Can you see what that is? Now, if you can't read that, just go 16 times, whoops, clear that out. 16 times 16 equals 256. You see how I wrote it out in words just so to help you make sense out of it. But can you say when you make your place value charts, you might just put the decimal numerals up there because it's easy to work with them. So what do I have here? Now watch, I'm going to translate from base 16 to base 10 to decimal. So I have A in the 256 column. What's A stand for? 10. So I have 10. What's 10 times 256? 2,560. You follow that? Everybody follow that? How come the adrenaline's not pumping? Oh. What's 16's place is C. What's C? 12. So I have 12 times 16. I'm not going to do that in my head. What's 12 times 16? 192. And then I have 14. No. I have E in the ones place. What's E stand for? 14. So I add 14. So what's 2,560 plus 192, which is 12 times 16, plus 14, 2,766. So watch this. ACE in the base 16, this is so much fun to write this, equals 2,766. I mean, that just messes with your head, doesn't it? When you put the two systems right next to each other. That's why when I'm doing the work, I put the one they give me over here and I put my answer over here, so I don't get confused by looking at both ends of it right next to each other. Because that looks a little scary. I mean, it's like that's just messing with my head doing that. That's giving me a headache. Okay, so let's move on to number 18. 17 through 32. Now, this is what the book asks you to do, so we're going to do it. Even though you could be using place values to do this, but we're going to do it their way because I'm going to show you what the book wants you to learn. And for 17 through 32, they want you to use the method of successive division. So I've got it written out here, but I think I'm going to do it again in blue. Can you see that blue up there okay? Oh, let's do it in red. Let's stick with red. Okay, so watch what I'm going to have. I'm going to say 27. Then I'm going to divide by 5. You say, why? Because 18 says, write the number 27 in base 5. So I divide by 5. 5 times what? I mean, if I put 27 up here and said divide by 5, what would you do? You'd go 5, 25, and have a 2 remainder. So it's 5 with a remainder of 2. Everybody follow that? Then I come down here again and I divide by 5. They just put the division sign upside down and I get 1 with a remainder of 0. All right, I'm going back to black now. So watch what this means. 27 in decimal equals, watch this, 1, 0, 2 in base 5. You go, what? Okay, now what was base 5? 5 to the 0, 5 to the 1, and 5 squared. Agreed? What's 5 squared? 25. 25. No 5s and 2 1s. What's 25 plus 2? 27. So 27 is, go back to red, 102 in the base 5. And after you've done it, you can go back and look at your place value chart to check to see if you've got it right. You go, why would I do that when I could just check my homework by going to the back of the book? Because it's fun playing with 2 or 3 or 4 different mathematical languages. Well, that's a matter of opinion. Number 20. 43 is my number, and I want to put it in base 2. You say, it doesn't say base 2, it says binary. Okay, put that in your notes. What does binary mean? Like a bicycle? 2 wheels? Binary is a name for base 2. So that means I divide by 2. 43 divided by 2 is 21. Let me erase this. Is 21 with a remainder of 1. Everybody follow that? 43 divided by 2 is 21 and remainder 1. Okay? 21 divided by 2 is 10, remainder 1. 10 divided by 2 is 5 with no remainder. 5 divided by 2 is 2 with a remainder of 1, and 2 divided by 2 is 1 with no remainder. Okay? So we're basically done with it. I suppose you could add one more step if you want to. It doesn't matter. You could say, well, what if I divide this by 2? Then you get 0, remainder 1. So then, what's the numeral? Well, if I followed the pattern, I would have 0, 1, 0, 1, 0, 1, 1 in the base 2. But if this is the last place and it's a 0, you understand it doesn't count for anything. So this would be my answer, which is what I have right here. 1, 0, 1, 0, 1, 1 in the base 2 is the same as 43 in the base 10. And just to make sure, I put my place values up here for base 2 and then did the math down here. Did the math down here to show what I was doing, just to check it out. Because I would rather build the place values, and actually by building these place values and doing this, you're gaining more experience working with it, and you're fixing things in your head. So if you ever see this again in the future somewhere, it'll make a little more sense to you. I mean, did you come here to learn math or just to pass the test? Don't tell me. I don't want to hear if it's not to learn math. Page number 22. Number 22 says, write the number 121 in hexadecimal notation. Oh, you don't know what hexadecimal is? Well, hexadecimal is a name for 16. So put down in your notes, when it says hexadecimal, that's base 16. And by the way, when we get down to 28 and it says octal, anybody want to guess what octal is? Base 8. Have you studied Latin? Or you just know that stuff? You studied Latin? People who study Latin understand the basis of a whole bunch of things that we do in English. Okay. So, what's 121 divided by 16? You go, I can't do that in my head. So watch what happens. I get my calculator and I go 121 divided by 16 equals, and here's what I get, 7.5625. That is not going to do me any good. But if I get 7, then I know I put a 7 down here. So what's 7 times 16? $112. So what's my remainder? I go 16 times 7 equals 112, and then I go minus 121 equals 9. So I have a remainder of 9. You see that? In other words, when I use my calculator, it's gonna do the division to the nearest decimal place, and I'm just looking for the nearest whole number, and then I'm going to have to come back here and find remainders. Unless you have a calculator that will do division and show remainders. And you won't buy those for $5 at Office Depot. You'll pay more like 50 or 60 for those. So I'm thinking if most of you have these little cheapies, then just say, okay, I divide 121 by 16, divided by 16, equals 7.5625. I use the 7. I put the 7 down there, and then I take 7 times, because if I take 7 times 16, and I get 112. Subtract 112 from 121. I'll just let the calculator do that. And I mean, it says negative 9, but I know it's 9, so I put remainder 9. Then I divide 7 by 16, and what do I get? I get 0 with a remainder of 7. You can see that one, can't you? And what did I do off here to the right? Just for fun, I just made a table of 16 times 15, 16 times 14. You go, why'd you do that? Because the highest digit in base 16 is 15. So I just made a multiplication table for base 16. Just because when I was doing this stuff to get ready for class, I thought, wouldn't that be fun to have that off to the side just staring at me? So you can take every one of these bases and make a big multiplication chart that you can look at if you don't want to take your calculator and meander through all this machinations, whatever you want to call them. So what's the answer? Okay, watch how we write the answer here. I'll go to green now, or blue. 0, 7, 9 in the base 16. And then I go back and check it. 9 1s and 7 16s. 112 plus 9 is 121. Yep, I did it right. Who needs to look at the back of the book? Number 24. 38 divided by, 38 in base 6. So I divide by 6, and I go 38 divided by 6 equals 6.333. So I put 6 down here. See that? And 6 times 6 is 36. You go, I knew that. Okay, sometimes you use your calculator when you don't need to. So that means I have a remainder of 2. Then 6 divided by 6 is 1 with a remainder of 0. And if you want to keep going, then 6 divide this by 6 and you get 0 with a remainder of 1. And you know when you get down to 0, there's nothing left. So then what's this number going to be? 0, 1, 0, 2, which is the same as 0, 1, 2. You follow? 1, 0, 2. You follow that? That if there's nothing, if it's a 0 in this place, then there's nothing there. Okay? Number 26. How many of these are we going to work? 123 in base 7. So I go 123 divide by 7 equals, and I get 17. So then I go, what's 7 times 17? Oh, I already have that down here. Since I made a little table, it's 119. So I go 123 minus 119 equals, and there's my remainder 4. You follow what I'm doing to find these remainders? Because the remainders are going to tell me what the numerals are for the new base. And then what's 7 divided into 7? 17. Remember, that's like 17 divided by 7. And if you need to take a piece of scratch paper and do this on the side, that's okay. And that's 2 7s is 14. 3. So it's 2, remainder 3. Everybody see that? And then what's, oh, and then, yeah, and then I divide 2 by 7 and I get 0, remainder 2. So what's my answer? 0, 2, 3, 4, which is the same as 2, 3, 4 in the base 7. Isn't that cool? 2, 3, 4 in the base 7 equals 123. See what happens when you put them right next to each other? It just really hurts your head to see them right next to each other. But that's what's going on. Number 28. Have we done an octal one? Oh, we haven't. Okay, then let's do it. 135 divided by 8 is 16. So I put down a 16, and I take 16 times 8 equals 128. And what's 135 minus 128? 7. So my remainder is 7. Then I divide 16 by 8, and I get 2, remainder 0. Then I divide 2 by 8, and I get 0, remainder 2. So what's my answer? Remember, you go this direction when you're reading it. 0, 2, 0, 7 in the base 8, which is the same as 2, 0, 7 in the base 8. And don't say 207. That kind of pronunciation is only for the decimal system. It's 207. Okay, I think we've done enough of that. I mean, I did 30 just for the fun of it. Well, maybe we ought to walk through 30 real quick. Number 30, it says 145,263 in base 16. So I follow this same process. I take 145,263 divide by 16 equals, and it equals 9078.9375. But see, all I want is the 9078. Then I take 16 times 9078, and I get 145,248. And what's that minus 145,263? 15. So my remainder is 15. Or you could put 145,263 up here and then subtract, and you get the same answer, 15. Okay? Then I take 9078 and divide by 16, and I get a remainder of 6. Then I take this and get a remainder of 7, and I take this and divide this by 16 and get a remainder of 2. Oh, 35 by 16. 2 16s is 32, remainder of 3. So my answer is 0, 2, 3, 7, 6, and 15. But what do I mean 1, 5. What do I do with 15? 15 is F. So I put an F in there with base 16, and there's my answer. All right. I don't think. Stop at problem 31 and turn over to page 213. .4. And just to let you know, we stopped at 31 on that exercise, so we're going to stop at 23 on this page. So for 4.4, stop at 23. Now, watch this. This is so cool. Okay, maybe since it's see, all of this stuff is in binary. So it says, problem number 2, look what it says. 111 plus 101. Draw a line and add. Okay. Maybe we ought to put up here, since this is all binary, which is base 2, we ought to put out here 2 to the 0, 2 to the 1, 2 to the second, 2 to the third, 2 to the fourth, and this is 1s, this is 2s, this is 4s, this is 8s. Okay? Now, what's 1 and 1 in your head? When you add 1 and 1, what comes to mind? I mean, we think in decimal, so let's go ahead and think it. What's 1 plus 1? 2. Now, how would I say 2? How would I say 2 in binary? 1, 2, and no 1s. Everybody follow that? Binary. 2 would be 1, 2, and no 1s. So, see if you can figure out what's going to happen here. 1 plus 1 is going to be a 0 and carry the 1. Is that cool? Because you had 2 places. So you do that. When you have 2 places, you put the last one down and carry the other one. So now, what's 1 plus 1? In other words, 1, 0, that equals 2. Okay? What's 1 plus 1? In your head, what's 1 plus 1? 2. How do I say 2 in binary? Put down a 0 and carry a 1. You follow that? This is 2 right here. 1, 0. Oh, somebody's head is hurting big time. Okay? So what's 1 plus 1 plus 1? 3. Anybody want to guess how to say 3 in binary? What?
1, 1.
I have a 2 and a 1, so I go 1, 1, and that equals 3. Everybody see that? So 1 plus 1 plus 1 is 3, so I go 1, 1. So the answer to this problem, 1, 1, 1 plus 1, 0, 1, is 1, 1, 0, 0. Now, let's just go ahead since we started doing this. So if 1, 0 is 2 and 1, 1 is 3, what would be 4? Look at the chart. What would be 4? 1, 4, no 2s and no 1s. What would be 5? 1, 4, no 2s and 1, 1. What would be 6? See how you can build you a kind of a little table of values? 1, 4, 1, 2, and no 1s. What would be 7? 1, 4, 1, 2, and 1, 1. Everybody follow how you can build a chart to kind of help get your mind adjusted to this? Okay, let's go back to black again, and let's work problem number 4. 4 says 1111 plus 1101. Draw a line and add. And what's 1 and 1? 2. How do I say 2? Put down a 0 and carry a 1. What's 1 and 1? 2. How do I say 2? Put down a 0 and carry a 1. What's 1 and 1 and 1? 3. How do I say 3? 1, 1. Put down a 1 and carry a 1. And what's 1 and 1 and 1? 3. So there's my answer right there. You like that? Okay, let's do some subtraction. Oh no, let's do number 6. Because number 6 has them lined up here. Number 6 says 1101, 1110, and 101. What's 1 and 1? 2. How do I say 2? 0 and carry the 1. What's 1 and 1? 2. 0 and carry the 1. What's 1 and 1 and 1 and 1? That's 4. How did I say 4? Whoa, 1, 0, 0. So I put down a 0, a 0. Actually, I put down a 0 here, a 0 here, and carry a 1 over there. What's 1 and 1? 2. 0 and carry a 1. What's 1 and 1? 2. 0 and carry a 1. So there's your answer. I should make these zeros a little bigger. 1, 0, 0, 0, 0, 0, 0. 0. Put on too many zeros. Now that you can do addition, how about doing subtraction? Number let's do number 8, I guess, since it's there. Go back to black. Let's do number 8. What does 8 say? 1, 1, 0 minus 1, 1. Now we're doing subtraction. So I have no 1s, and I'm going to subtract 1, 1. Can I do that? Can you subtract 1 from nothing? I mean, if I had 34 minus 17, can you subtract 7 from 4? So what do you have to do in decimal? You borrow. You change that to a 2 and make this 14, and then that leaves 7 down here, and then that leaves 1 here. Agreed? Well, let's apply the same principle here. I don't have any 1s, but I have 1, 2, and 1, 2 would make 2 1s, wouldn't it? So I borrow this, which means I take that out and turn that into a 0. And 2 1s minus 1 1 would leave me 1 1. Yeah, but now I borrowed those 2s. Now I'm in trouble because I have no 2s and I want to subtract 1 2. Well, go over here to the 4s. I have 1 4. And 1 4 would make how many 2s? Let me change colors here again. I have 1 4. 1 4 would make how many 2s? 2 2s. So I have 2 2s. Whoa, what's that all about? Where'd it go? Even the tablet doesn't like doing binary. Oh my goodness. Okay. Let me see what's happening here. I sure don't know why it's messing up like this. Oh, come on. Anybody have an idea of why it's doing this? My goodness. Huh. All right, let's go back here and start this thing over again and see what happens. Yeah, that's where we were. Let's see if we can get back in here and do something. I don't know. These things have a mind of their own. So I have 4 2s, and I cancel out the 4 2s. So I have I have 1 4, so now I have no 4s, but I have 2 2s. 2 2s minus 1 2 is 1. And of course, since I borrowed that one, it's gone. So now I have, here's my answer, 1 1, when I do that subtraction. You guys don't like subtraction, huh? Well, let's do number well, they're all going to be like that. Number 10. What's number 10 say? 1101 minus 111. Well, this will be easy. 1 minus 1 is just 0, right? But then, now watch. Since it's binary and it's base 2, see if you can make this adjustment in your head. 1 of these equals 2 of these. It always works that way. When you look at the place values, 1 4 equals 2 2s. 1 8 equals 2 4s because it's base 2. So I just mark out this 1. It becomes a 0, and I put a 2 over here. So what's 2 minus 1? 1. 1 from 0, I can't do that. So this becomes 0 and this becomes 2. 2 minus 1 is 1. You follow me? Since it's base 2 and I only have 1 and 0, when I'm borrowing to subtract, I don't have to use all the digits like when you're borrowing decimal, then it goes 13, 14, whatever, you add that 1 in front of it. Well, since it's base 2, it's just always 2. Let's do number 12. Just for fun. 1010 and minus 101. Okay, I can't subtract 1 from 0, so let's go back up here to red. So I turn this into a 0 and I have 2 of these. 2 minus 1 is 1. 0 minus 0 is 0. 0 minus 1, I can't do that. So this becomes 0 and this becomes 2. 2 minus 1 is 1. You follow the thinking? Yeah, it's starting to register. Well, we're out of time. Those of you who want to correct your test, it's up here. So now that you've been introduced to this, if you work on addition and subtraction between now and Monday, on Monday, when we do multiplication and division, it'll be a lot easier. If we had to do addition, subtraction, multiplication, and division all in the same day, it would really give you a headache. You already have one? I see a few smiles out there. So maybe for some of you, some of this is starting to soak up into your minds. Have a nice weekend, and I'll see you on Monday. And we'll finish, what'll happen is we'll finish 4 and go work on 4.5, just in case you want to know where we're going next. Yeah, for today, for today, stop at 11. Stop at 11. Yeah, let me write that down there. Stop at 11. Because we'll do the others. We'll do the others on 4.4. 4.4, stop at 11, and then I'll give the rest of them, I'll assign the rest of the problems on Monday. Oh, and don't take your test out of the room. I mean, go ahead and sit here and correct them, and I'll help you if you have a question, but don't take them outside the room. After you get them corrected, bring them back. If you don't have enough time to finish, just bring it back and hand it to me personally and say, can I work on this some more on Monday? And the answer is yes, I'll give it back to you on Monday. Thank you for the homework.
I have a question. Will we have to test next week on Wednesday, Friday?
Let's see. If we do 4.5 on Monday, and will we do the practice test? Yeah. We'll do the practice test on Wednesday and take the exam on Friday.
Is there any way I could take it online or take it early? Because I'm trying to, my family's spring break is next week instead of the week after, like ours is. And so I was trying to go home to see my family.
So would you rather take it earlier or take it when you get back?
Can I take it when I get back?
Yeah.
Okay, thank you so much.
Then you'll have time to look at the practice test on
Yeah.
the video to see what covered and get all that help.
Okay, thank you
All
so
right.
much.